Hello everyone. So welcome back to the Enterprise Dev channel. So in our previous video, we learned about monitoring and observability, right? So today, mm, today we will take the next step and understand the Prometheus architecture. So if you ever wonder how does Prometheus collects metrics, what are the exporters, and why do we need push gateway? What is service discovery? What is TSDB? How does Grafana get data? And how her alerts are sent to this Slack or email. So then this video is for you. So by the end of this video, so you will understand the complete Prometheus architecture from end to end. So let's start. Welcome back to the Enterprise Dev channel. So first thing first. So what is Prometheus? Okay. So Prometheus is okay. So I'm telling next slide. Okay, this is slide is best. So first thing first. So what is Prometheus? Prometheus. So Prometheus. So Prometheus is open source. So open source monitoring and alerting system. So its primary job is to continuously collect metrics from application, servers, containers, database, and the Kubernetes clusters. So what is the purpose for this Prometheus? Continuously collects metrics from application, server, containers. Okay, wait this. So containers and Kubernetes clusters, DBs. So that is the main for Prometheus. So think Prometheus as a daughter who regularly checks patient's health. Okay, like doctor. So it continue like regularly checks the patient's health, right? Same way Prometheus also does. So like Prometheus checks CPU usage, memory usage, okay, memory usage, disk usage, request count, request count, error rate, and response time, JVM metrics. So these are it collects these metrics, store them and analyze them, and generates alerts whenever the something unusual happens, something is happens. So this is about Prometheus. Okay, this is about Prometheus. So next we have architecture. So you can directly check in the net for this architecture. So I have taken from that. So let's understand the architecture shown in the diagram. So instead of looking at all the boxes together, let's follow the order from left to right. Okay, left to right. So first and foremost thing. So this is thing. So this is what is this export jobs and exporters. So suppose we have an application. Okay, application is the exporter. Okay, application is one of the exporter. So application exports the some metrics. Okay, application exports the metrics in this exporter. After that, we have push gateway. So after that we have push gateway. After that we have service discovery. In service discovery we have Kubernetes and file HT. After that we have Prometheus server, retrieval, TSDB, HTTP server, HHD, SSD. After that we have PromQL, Prometheus web UI and Grafana. So and API clients, Alertmanager, pager to Slack. So once you understand this flow, you will understand almost everything about Prometheus. So this is we are telling from left to right. Okay, first one is Prometheus targets or exporters. We can call it as Prometheus targets and exporters. So let's start from bottom left corner of the architecture. So these are the called Prometheus targets. So target is simple, like simple anything Prometheus can monitor. So that is a target. So it include examples like so in targets we have many things like application, okay, Linux servers, okay, MySQL, Kafka. These things are in the egg targets. So most of the application don't expose the metrics in Prometheus from by default format by default, right? So that's why we use exporter. So suppose we have application, so we are sending the metrics to this target, one of the format x format, but exporter use another format. Okay, another format. So that's why exporters will do the formats. This is some common exporters are like so common exporters. We have node exporter and MySQL exporter. So these things we can see in that exporter. So mainly an exporter collects information from the application or system and exposes it in the format that Prometheus can understand. Okay, so mainly so exporter it collects the information from application, Linux server or Kafka or Kubernetes. So and it exposes it in the format Prometheus can understand. For example, so node exporter. Okay, so node exporter exposes a metric such as CPU, memory, disk, and these things. So Prometheus will later scrap this matrix. Okay, next one. So up to now this is matrix completed, exporters completed. So after that we have push gateway. Okay, you will see here short-lived jobs connected to push gateway. So normally Prometheus uses pull-based model. Okay, so in periodically requests metrics from applications. Request a matrix from application, but some applications exist only few seconds, like only few short-lived projects. So like backups, okay, like backup jobs, batch processing, cron jobs. So these are the short lists. So these jobs may finish before Prometheus has chance to scrap them. Okay, so that's why. So instead of waiting, so these short-lived jobs push their metrics to the push gateway before exiting. So mainly like the short jobs metrics will push the metrics to the push gateway. So after that it will be exit. After some time, so Prometheus scrap metrics from this push gateway. That's why we have push gateway exist. So it mainly used for the short-lived or bad jobs mainly. So after that we have service discovery. Okay. So imagine how you have only one server. So configuring Prometheus manually is easy. Okay. So what if your Kubernetes cluster has 500 pods and 100 services? New pods being created every time. So manually updating Prometheus configuration would be impossible, right? For this case. So this is where Prometheus has service discovery helps. So Prometheus automatically discovers monitoring targets. Okay. So Prometheus automatically discovers the monitoring targets. Yeah. So some common discovery mechanisms are like Kubernetes and file SDs and EC2s, EC2, Azure. Those things we have common discovery mechanisms. So whenever a new pod starts, so Prometheus automatically detects it and begins scrapping metrics. Okay. So whenever new pod is created, so Prometheus automatically detects it detects it and begins the scrapping the matrix from this. So no manual configuration is required. So we have next we have Prometheus server here. Okay. So the Prometheus server, this is a brain of entire monitoring system. So inside the server, you can see three main components. One is a retrieval, one is a TSDB, one is a HTTP server. So retrieval is nothing but this is a common this is a component periodically scraps metrics from all all discovered targets. Okay. So mainly this is a retrieval means it scraps the metrics from the all discovered targets. Like so we have targets right here. So it will mainly it collects the metrics from this here to here. So for example, every 15 seconds, so Prometheus sends a HTTP request to the application metrics endpoint. The application responds to with the latest endpoints and retrieve the collect those metrics. That is the thing. So another one is TSDB. So TSDB is a time-based database. So after retrieval, so these metrics are stored in this TSDB. So TSDB is a time-based database, unlike MySQL and Postgres. So Prometheus stores data as a metric name, okay, metric name and a timestamp and value. Okay, suppose suppose. So we have metric name CPU uses timestamp 10 a.m. So value 65% like that. It will store in that. It will store in the DSTP like this. So since every metric changes over time, right? So that a time-based database is perfect choice for this Prometheus. Next one we have HTTP server. HTTP server exposes Prometheus APIs. So mainly like we have Prometheus, right? If you want to connect with the Grafana, so we can use this HTTP server so that we can directly we can expose the this metrics to the Grafana. That's why we are using Promo, and also we can use this Prometheus web UI. So that is the use of HTTP server. So next one we have PromQL. So here you can see PromQL, right? So PromQL so stands for the Prometheus query language. So Prometheus query. lang. So think of from PromQL like SQL. Okay. So SQL mainly what SQL means retrieves the information from relational database, right? But PromQL retrieves the metrics from Prometheus. For example, so if you want current CPU uses, so we will directly get the, if you want a HTTP request count, so that we can get pod restart count, so with that we can get that. So uses Grafana uses PromQL behind the scenes to fetch the metrics. So we will learn PromQL in separate video. Okay. So next thing we have Grafana and Prometheus UI. So now let's move into this. So Prometheus provides its own web UI. So you can we can search the metrics and you can execute the PromQL queries. We can see the basic graphs. So but for beautiful dashboards, we can use the Grafana. So Grafana connects to the Prometheus. It doesn't store data mainly. Instead, it queries Prometheus using PromQL and creates the rich dashboards, rich visualization dashboards like a CPU dashboard, memory dashboard, Kubernetes dashboard, like that we can create. So mainly like PromQL, using PromQL, we will get uh, these metrics to the Grafana. We can directly get that is a use here. Next and final portion is Alertmanager. So now let's move into the Alertmanager. So monitoring isn't useful if nobody knows something has gone wrong, right? So Prometheus continuously evaluates alert roles. Suppose, for example, if if CPU uses 90%, get the usage is 90%. So for every 5 minutes, alert is triggered. So Prometheus sends uh, this alert to the alt manager. So alt manager decides who should receive it. Should it go to the email or Slack or Microsoft Teams or pager duties? So we can configure those in this alt manager, pager duty, email and things. So alt manager also supports grouping, silencing and deduplication and routing. So this prevents engineer from receiving hundreds of duplicate alerts. So you can see real production flow. I will tell you for real production flow. So imagine a customer opens your shopping application. Okay. Okay. Your customer opens shopping mm, application. Customer opens a shopping application. The request reaches your Spring Boot application. So that is running on Kubernetes. So now node exporter, okay, node exporter exposes the infrastructure metrics and Spring Boot exposes application metrics. Prometheus discovers those the pod automatically. So every 15 seconds, Prometheus scrap these metrics. So these metrics will be stored in this TSDB DB and Grafana queries queries the Prometheus. Okay, Grafana queries this Prometheus and it display dashboards like this. Suddenly, so CPU percentage has been reaches to 90%. So Prometheus evaluates this alert role. An alert manager receives an alert. An alert manager sends notification to email. So on-call engineer should investigate the dashboard. Okay. After that, he will check the logs in this and identify the issue and restore the application. So by this entire flow happens automatically. You don't need to do manually. So that is about total. So I hope this video helped you understand the Prometheus architecture from end to end. So in this video, we will explore the in this video we will explore the pull based versus push based model. Understand why Prometheus prefers pulling metrics and see how push gateway fits into the architecture. If you found this video helpful, please like, share, subscribe to the dev channel, the enterprise dev channel. Thank you for watching. I will see you in the next video.